Hey everyone, and welcome. Have you ever clicked a button in an app and then nothing? The whole thing just freezes up? Well, that frustrating little spinning wheel is often the line between good code and, well, bad code. Today, we're going to pull back the curtain on the magic that keeps our favorite apps feeling fast and snappy, asynchronous programming. Let's dive in and see how developers keep our digital world from grinding to a halt. So it really all boils down to two different ways of thinking about code. First up, you've got synchronous code. Now, you can think of this like a single file line at a coffee shop. One person has to order and get their drink completely before the next person can even start. And then you've got asynchronous code. This is more like a talented juggler who can keep multiple balls in the air at once without dropping any of them and bringing the whole show to a stop. All right, so let's dig into that first idea, the synchronous roadblock. I mean, doing things one at a time sounds simple, right? It's predictable. But it has this one giant weakness. Especially today with web apps that are constantly fetching data, loading images, or just waiting for you to do something. And that leads us to the most important question of all. If your application is just working its way down a to-do list one item at a time, what on earth happens when one of those items is something like, go download a huge file or wait for a really slow server to respond? You got it. The entire application just freezes. This is what we call blocking. That button you clicked is stuck, the screen won't update, absolutely nothing happens because the single main part of your program is completely tied up, just waiting. And that, as we all know, is a terrible user experience. So how do we get around this? I mean, how does a language like JavaScript, which is famously single-threaded, meaning it can technically only do one thing at a time, somehow manage to power these incredibly complex and responsive apps we use every day? Well, to understand that, we have to look inside the engine room. And the hero of our story, the absolute secret sauce, is something called the event loop. You can think of it as the app's traffic controller. It's this process that's always running in the background, making sure that the main highway, our main code, never gets clogged up by a slow-moving truck. So here's how it all works. An asynchronous task starts. Let's say we're fetching data from a server. Instead of making everyone wait, the engine hands that task off to a special area called the thread pool. Now, the main code is free. It just keeps on running. And this is the most important part. When that data fetching task finally finishes, a little note, its callback, gets put into a waiting line called the event queue. The event loop is constantly checking that main highway. The second it's clear, it grabs the first thing from the queue and runs it. This whole cycle is what makes everything feel so instant. Now, managing this whole handoff process hasn't always been so straightforward for developers. The way we've written this kind of code has actually evolved a lot over the years, moving from something that worked but was, well, pretty messy, to something much, much cleaner. The original way of doing things was with something called callbacks. A callback is pretty much what it sounds like. It's a function you give to another function, and you basically say, hey, run this for me once you're done with your main job. It's kind of like the call me back when you're finished of programming. But there was a big problem with this. If you had a bunch of tasks that all depended on each other, you'd end up nesting callbacks inside of other callbacks, inside of more callbacks. Your code would start to look like a pyramid tipping over, and it just becomes, as you see here, hard to read. This makes finding bugs and just maintaining the code a real nightmare. So developers needed a better way. And that brings us to promises. Promises are a much more modern solution, designed from the ground up to make handling these asynchronous results way cleaner and a whole lot more predictable. Okay, so what is a promise, really? Let's take a closer look at how this elegant solution actually works under the hood. A promise is, well, it's pretty much exactly what it sounds like. It's an object that acts as a placeholder for a future result. It's a guarantee from your code that eventually you'll get something back, either the successful data you're hoping for or an explanation of why things went wrong. You see, every single promise exists in one of three states. It always starts as pending. That means it's still working, the result isn't in yet. If everything goes well, it transitions to fulfilled, success. And if something breaks along the way, it moves to the rejected state. This built-in state management is what makes them so powerful and reliable. And here's what that looks like in actual code. You create a new promise. You give it a function, and that function gets two really important arguments, resolve and reject. Think of them as two doors. Inside this function, you do your async work. If it succeeds, you call resolve and send the successful result through that door. If it fails, you call reject and send the error through the other one. So how do we actually use the promise? This is where it gets really elegant. We just chain methods onto it. The .then method will only run if the promise was fulfilled, if it went through the success store. And the .catch method will only run if the promise was rejected. So you get these two beautiful, clean, separate paths, one for success and one for failure. No more messy nesting. So let's tie this all together. Why does any of this really matter? Well, because promises make our code so much cleaner and easier to understand, which directly solves that hard-to-read nesting problem from the callback days. They give us a standard, predictable way to handle both success and errors. And at the end of the day, this solid foundation is what lets developers build the powerful, fast, and responsive apps that we all depend on. And that's really the secret behind it all. It's not about making the computer do things faster, it's about teaching it not to just sit around and wait. It's the simple but incredibly powerful idea of handing off a task and just saying, hey, let me know when you're done. So, now that you know the secret to responsive apps, what are you going to build?